Right at the end of the last video, I got cut off right after I said the word also. I always forget to look at the timer and see if I'm going over time. We found out that the traditional class had more variation in the scores. We didn't even look at their averages. We just wanted to know who had a larger spread. And it turns out it was the grades in the traditional class. But what I was going to tell you is that if you have the older calculator or if you have the newer calculator, it does look a little different on the screen, especially when you go into OneVar Stats. So what I wanted to tell you is that I posted a calculator handout in Canvas that's a PDF that explains the difference between the old operating system and the new operating system. So if your calculator doesn't look like mine, you can go pull up that handout and it'll explain how to use the older operating system. That's what I was going to say before I was so rudely cut off by my computer. All right, now let's talk about the empirical rule. The empirical rule puts together means and standard deviations and gives you a relationship between them. So here's what the empirical rule says, and it only works if you have bell-shaped data. And this is what it says. This is the mean. Of course, that's the center hump, right? There's your mean. And what we're going to do is we're going to take the mean and we're going to add one standard deviation, and that's going to move us over to this mark. You can see mean plus a standard deviation. Then we're going to add another standard deviation. So this is the mean plus 2 standard deviations. Then we're going to add another one. So it's the mean plus 3 standard deviations. And on a bell curve, most of your data is clustered here in the middle. You only have a few data points out at the ends. Most of it's here in the middle. So that's why this frequency is not very tall down here at the end. And then you can play the same game going to the left. You're going to subtract a standard deviation, then subtract another standard deviation, then subtract another one. And what we're interested in is how much data have we captured in each of these little chunks. So if you start at the mean and you go out one standard deviation, you have covered approximately 68% of your data. 68%. See, 34 and 34 makes 68. So how they got the 34s is they took this rule of 68 and they just cut it in half. So 34 and 34. Then if you move out another standard deviation, well, now you've captured about 95% of your data. Most of your data is within 2 standard deviations of the mean. I mentioned this earlier. If you go more than 2 standard deviations away from the mean, well, it's a little unusual. So how did they get 13.5? Well, we know that from left to right is 95, and inside here is 68. So if you subtract those, you get 27. And if you cut 27 in half, that's how you get 13.5. Okay. And then if you go out 3 standard deviations, man, you've got darn near all of it, 99.7%. which means there's only 0.3% left to share among the tails. And that's where that 0.15% came from. That's a dinky little amount. So you can either memorize 68, 95, and 99.7, but then you're going to have to do the math to get all these individual ones. So what I'm going to suggest you guys memorize is you memorize these. 34, 13 and a half, 2.35, and 0.15. That I highlighted there in orange. I think you should memorize these. And then they just duplicate over here on the other side. So you just have to memorize these 4. They should add up to 50% if you did it correctly. So this picture, this is what we're going to use to answer some questions, some word problems. And word problems usually will say something about the empirical rule. So you'll know when it's time to use this. I like these questions. These aren't too bad. So it says, IQ scores of normal adults have a bell-shaped distribution. You have to know it's bell-shaped. With a mean of 100, mean is 100, and a standard deviation of 15. Now I'm using population notation because we're talking about the IQ scores of all adults. Then the instructions usually will say, use the empirical rule, and then they'll ask you the questions. But in the notes, it's right after empirical rule. So what you're going to do, you're going to create a picture with the parameters labeled, and you're going to compare that picture to this one, and then you're going to be able to answer the question. So we're basically going to recreate this, but with numbers along the bottom that go with IQ scores. So the mean, right here in the middle, let's do this in blue, mean is 100. That's your starting point. And from there, you want to add the standard deviation. Let's go to the right. If you add 15, you get 115. Add 15 again, you get 130. Add it again, you get 145. And if you want, you can put the vertical bars in here. Okay, so we added the standard deviation. Now play the same game, go the other direction. If you take 100 and subtract 15, you get 85. Subtract 15 again, you get 70. Subtract again, you get 55. And again, I'll draw the bars in here. Okay, now let's fill in the percents. From the last page, I know that this is 34%, so is this, and then 13.5%, and then we've got 2.35% and 0.15%. No, they're teeny tiny to write them in there, but they should match. And furthermore, when you add all these up, you should get 100%. This left half should be 50, the right half should be 50, they should match, okay? All right, now it says approximately, because this is all just a general rule of thumb, it's all approximate. Approximately, what percentage of adults have IQ scores between 55 and 145? And I think it's helpful if you'll use sticky notes. So between 55, which is there, up to 145. I just want to add up the percents that are there, okay? Now you can use the empirical rule on the last page, or you can just do a quick add on your calculator. 2.35, 13.5, 34, and then you know what I'm going to do? I'm just going to double it because those match. 99.7, approximately. Approximately 99.7%. I think rather than memorizing more percents, I think it's easier just to add them all up. Okay, let's look at the next one. Approximately what percentage of adults have IQ scores greater than 145? So we just want to go greater. And that one you can see it's really easy, 0.15%. Approximately 0.15%. Not very many adults have IQ scores greater than 145. That's pretty unusual. And then it says what percentage of adults have IQ scores between 85 and 130. So we block off, here's 85 and here's 130. So between 85 and 130, that's not a symmetric region. That one you got to add them up. You've got 34, 34, and 13.5. 81.5% approximately. But you have to know that you're looking at bell-shaped data before you can use the empirical rule. So draw a picture, label your percents. You have to memorize the percents. And then you can use sticky notes or your hands or whatever you need to use to cover up the regions. All right, let's try another one. SAT math scores have a bell-shaped distribution. See there, it said it again, bell-shaped distribution. This time, the mean is 515 and the standard deviation is 110. Again, we're talking about all SAT math scores, so I'm using population notation. Notice how huge the standard deviation is. That's because there's a ton of variation with SAT math scores. So what I would like you guys to do, and you can pause the video and try it on your own, but you want to label your parameters, draw the curve, label your percents, and then try to answer the two questions. So I'm going to draw the picture. I'm not going to talk a whole lot while I do it, but you really should try one on your own. And then you can check against mine. So we'll start you there. There's your mean, 515. And remember, you add 110, add 110, add 110, and then you subtract 110, subtract 110, subtract 110. So I'm going to do that and not talk. Once you get all your parameters labeled, you can attempt to draw a bell curve in there. I'm not judging if yours doesn't look perfectly symmetric. Mine's not all that awesome either, and I don't even think my mean is in the center. But let's just pretend it was. I'm going to label my percents. And then you should be able to answer the questions. Approximately what percentage of math scores are between 405 and 735? Okay, if those numbers don't appear on your number line, you probably did something wrong. So those should be there. Between 405, which is right there, and 735, which is right there. Well, that sure looks a whole heck of a lot like another region we did on the previous example. 34, 34, 13.5, 81.5. And then, what percentage of math scores are lower than 405? Lower than 405. So we want to ignore all of that. We just want lower than 405. So we're looking at 13.5, 2.35, and 0.15. Make sure you get your decimals in the right spot. 16%. So if you can draw the picture and get those percents labeled, I don't know how you can miss them. They're pretty easy once you get the picture drawn. But you have to be able to draw the picture, and I cannot say this enough, you must memorize your percents. It does not help you if you don't memorize your percents. So that's the empirical rule.